welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze the water bottle for its modal analysis. We will start by double-clicking on the modal module. Next, we'll go to engineering data and double-click. Engineering data sources, general materials. Now, materials used for making of the water bottle are generally aluminum alloy. We have copper alloy. Then we have stainless steel as one of the prominent material, and then plastic, so polyethylene as the material. So these are four of them. Then I'll go to project and update project. Next I'll go to geometry and right click and import the model of the water bottle. Then I'll go to model and double click. We'll first go to geometry, and here I'll change the material to stainless steel for the body and the cap both. Then I'll go to mesh and I'll choose the default size and generate the mesh. Then we'll go to model A5 and insert fixed support at the bottom end and apply. So this is the only boundary condition which you need to apply. Then we'll go to solution and solve. So you can see here there are 6 modes and 6 frequencies that are generated. These are the 6 natural frequencies of the body. We got 6 because if you check here in the analysis settings part, max modes to find are 6. If you want, you can increase or decrease this number. I will leave it to 6 itself. Then you have to click here, right click, select all, right click, create mode shape results. You can see here 6 results have been formed for 6 modes. Then we go to solution A6 and solve. So you can see the results have been generated. We'll go for the first deformation, where the value of deformation is 0.82 meters. Again, a very large value. Let's change the unit from meter to millimeter. You can see here now it's 821.39 millimeter. A very large value of deformation for a frequency of 688 Hz. So this value of frequency should not be tapped for this bottle. Otherwise, you will have such a large deformation for this bottle. You can animate and check the pattern of its motion. Then we'll go for the deformation 2. Here the frequency is 693.6 Hz and the deformation is 822.27 mm. You can see the pattern of motion is different than the first one. Then we'll go for the third deformation. Here you can see the value of frequency is 2558.3 Hz, which is quite large than the first two. And the value of deformation is 1117.3 mm. You can see the pattern of its motion under this kind of a modal frequency. Then for the fourth one, deformation is almost similar to the third one, and the frequency is also very close to the third one. But the pattern of motion is what you can observe. This will be different for each of them. Then we have deformation 5, where the value is 793.49 mm. Frequency is 2740.6 Hz. You can check its pattern of motion. This is different than the rest 4. And the sixth one, where the value of deformation is 1082.9 mm and the value of frequency is 3004 Hz. Now this frequency is actually quite large. This generally does not get tapped, and that's why you never see these kind of deformations in the bottle. This is the pattern of its motion. Now this is for stainless steel. You can get the results for aluminum alloy. by changing the material, going to solution and solving once again. The pattern of motion for all the four material is going to remain the same. So you don't have to animate and check for all of them. You can check only for one material, but what is important is this value of deformation. Now let's see the deformation. It is 43.413 mm for a frequency of 697.81 Hz. The second deformation is 43.456 mm for a frequency of 703.56 Hz. You can see how drastically it has reduced. Then we'll go for the third one. It is 59.061 mm for a frequency of 2600 Hz. Fourth one is 58.99 mm for 2604.6 Hz. Fifth one is 41.945 mm for 2784.2 Hz. And the last one is 57 mm approximately for 3000 Hz. So you can see how the value has changed for stainless steel to aluminium for this same bottle. Now let's check for the third material, which is copper alloy. We'll go to solution and solve. We'll see the first deformation. It has further reduced 25.07 mm for 501.8 Hz. Now the frequency is almost the same for 3. It's actually close, not same, but it's closer. Then we can see for the second deformation, the values of 25.094 mm for a frequency of 505.96 Hz. In the third case, the deformation is 34.131 mm for a frequency of 1871.4 Hz. The fourth one is 34.055 mm for 1874.8 Hz. The fifth deformation is 24.214 mm for 2003.5 Hz. And the last one is 32.955 mm for 2198.9 Hz. So this is about copper alloy. Last we will check for plastic, which is polyethylene. Let's solve once again and see what happens to the bottle if it is made of plastic. So here you can see the 73.859 mm. This is more than copper and aluminium alloy, but it is less than stainless steel. So this is a very strange result that we have obtained, where you must understand that the modal frequency over here is different. Now see this value of frequency. It is 149.38 Hz. Steel was starting at somewhere around 500 or 600. Currently it is starting at 150 Hz. So obviously it is a lower value where you see this deformation. Then for the second case, the deformation is again 73.923 mm for 150.74 Hz. For third mode, you can see the deformation is 101.02 mm for 559.98 Hz. For the fourth mode, you can see deformation is again 100.52 for frequency of 561.37. 3/4 is again close. 5/6 also seems close. Let's see what happens. It is 71.13 mm for 599.58, approximately 600 Hz. And in the sixth case, it is 69.755 mm for 638.86 Hz. So you can see here that when you use plastic, it is going to be different. Okay, the pattern of motion seems to be a little different if you check. Let's see for the fifth one. Okay, this is same. Fourth one, pattern is the same. Third is same. This is also same. Only here you can see this has started twisting. But in those cases, only the neck of the bottle was twisting. In the first three cases, here I can see the entire body has started twisting. Maybe it's plastic, that's why it's showing, more amount of deformation. There the resistance was too high because they were metals, and this is a plastic. So obviously you can see more effect in this deformation 6. You can check the deformation once for all of them. to see if they are same. But for metals, yes, they will remain the same. For plastic, the last one is different. So with this, I end the session. I hope you have understood the comparative modal analysis of the water bottle. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.